Hi, this is Stan Lau with Master Math. During today's lesson, you're going to come across some You Try It pages. When you get there, hit your pause button, do the problem, and then hit the forward key to move on to the answer. I hope you enjoy yourself. In the last lesson, we talked about the domain and the range of a function, and hopefully you understand that. Today, we're just going to discuss a little bit more detail about the domain of the function. Now, hopefully you remember that if we had a function such as y equals 2x plus 3, the x values are the input value. You input a number for x, you replace x with a number, you manipulate it with the formula that's on the right side of the equation, and whatever you come up with is the y value. And the y value is the output value. Now, hopefully you also remember that all the potential values of x, all the numbers that could potentially work as x's, are known as the domain of the function. And all the potential answers that you could get, all the potential y values you could get, are called the range of the function. Now, all we're going to do today is go into a little bit more detail about the domain of the function and talk about whether the domain represents discrete values or continuous values. And it's really easy, and you're not going to have any problem with this. We'll give you an example to help you understand this. On the left of the screen, you see a Wheaties box with a star athlete on the cover. And on the right, you see a bowl of cereal, a bowl of Wheaties probably. Now, you know that if you went to the store and wanted to buy Wheaties, you probably couldn't buy a half a box. They probably are not going to cut up the box and give you just a portion. You got to buy a discrete unit of Wheaties. You got to buy a single box or 2 boxes or 3 boxes. But once you got that Wheaties home, you could pour yourself a half a bowl of Wheaties. You could pour yourself a full bowl of Wheaties. You could pour yourself a quarter a bowl of Wheaties. You could pour yourself 5 bowls of Wheaties. So the number of bowls of Wheaties you could create is continuous. There's no limitations. You could create 0.1, 0.6, 0.125, any size bowl of Wheaties. But the number of boxes of Wheaties you could buy is discrete because you have to buy them in units of 1 or 2 or 3. Well, let's take this example a little bit further and see if we can understand discrete and continuous domains. Let's say that the National Association of People Interested in What You Eat for Breakfast, and most people refer to this association as the NAPIWYEFB. The NAPIWYEFB conducted a survey of 5 families, each with only one 14-year-old child. They wanted to determine if there was a relationship between the number of boxes of cereal a family consumed and the weight of the child. They kept track of how many boxes of cereal, and we'll call X the number of boxes of cereal, each family bought during 1 week, and then they graphed this against the weight of the child, Y, and we'll call Y the weight of the child. And after they conducted this survey, they came up with this data. Family 1 bought 1 box of cereal, and their child weighed 136 pounds. And if we graph this, it looks like this. Now, you know from the last page, the last slide, that you can't buy a half a box of cereal. And we know that our domain in this case is discrete. It's not continuous. I can't buy 1.5 or 1.25 boxes of cereal. I've got to buy discrete units like 1 or 2 or 3. And when we graph it, we have discrete points on the graph. We don't have a line, we have discrete points. Why don't we have a line? Think about it. Why isn't there a line on this graph? Have you thought about it? Do you have an answer? Well, I do, and here's why. I don't have a line on here, because if I had a line on here, that would imply that I could go to a half a box right there and go up to the line and then come over and figure out what the weight of the child was. But I can't buy a half a box. I can only buy 0 boxes or 1 box or 2 boxes or 3 boxes or 4 boxes and so forth. So I'm only going to have points at 1 and at 2 and at 3 and potentially at 4 and at 5. I'm not going to have any points at 1.5 because I can't buy 1.5 boxes. So if you're graphing a discrete domain, it's not going to be a line, it's going to be a scatter graph with a series of points on it. Well, let's say this association of people interested in what you eat for breakfast conducted a different survey, and again they had 5 families, each with a 14-year-old child, and they still wanted to determine the relationship between the amount of cereal that the family consumed and the weight of the child. And this time they kept track of how many bowls of cereal, which we'll call X, each family consumed during the week, and then they graphed this against the weight of the child, Y, in each family. And they came up with this data. Family number 5 ate 4.5 bowls of cereal, and their child weighed 88 pounds. And family number 1 ate 20 bowls of cereal, and their child weighed 136 pounds. And when we graph this, we graph those points, but we drew a line through it, because there is an implication that you could have a partial bowl of cereal. If I had 5 bowls, it would be right there. But that, right at that point, is 8.75 bowls of cereal. So I could take any point on this line and it would represent an X value that made sense. Well, let's let you try one. The Bobcat baseball team has a team batting average of 356. The number of hits, which we'll call Y, they would be expected to get could be expressed as a function of the number of times they batted, X, and could be written as Y equals 0.356X. Is this a discrete or a continuous domain? Is this graph an appropriate way to represent the relationship? Hit your pause button, figure this one out, and then hit your forward key to move on to the answer. Well, let's think about it. We've got an X value, and the range of possible X values would be our domain. And we're trying to determine if our domain is discrete or continuous. And our X value is the number of times the team where it was at bat, the number of times batters were at the plate. Well, is that a discrete number or a continuous number? Could somebody be at the plate 1.5 times? Or could they only be at the plate 1 or 2 or 3 or a discrete number of times? Well, it's clearly the latter. Nobody could be at the plate 1/2 times. So the function is discrete. And when we graph a discrete function, it's not a straight line. It's a series of dots. So the correct answer is that this is a discrete function, and the graph that was originally on the screen is not an appropriate way to represent the relationship. Hit the pause key and try this one. When you get done, hit the forward key to move on to the answer. Okay, we're converting kilometers. Our input value is kilometers, or what we traditionally call an X value. We're calling K here. And our output value is M, or meters. And we're going to input some amount of kilometers and convert it through the equation or through the function into an amount of meters. So our domain is the possible number of values that could be substituted for k. Now, could we have a half a kilometer? Well, sure we could. Could we have 3/4 of a kilometer? Yeah, that would work too. In other words, they're not discrete units that we have to use in this. It's a continuous range of units from 0 up to infinity. And consequently, the domain of the input values is continuous. And the function would be a straight line like we've graphed here. Now you try this one. Hit the pause button, do the problem, and then hit the forward key to move on to the answer. Now Joe's selling some shirts and he sells them for $25 each, and you can tell that if he his revenue is going to equal the number of shirts he sells times $25. So we could write a function that said that. We could say that his revenue, or his total sales, equaled 25 or $25 times S, the number of shirts he sold. And in this function, S is our input value, and the number of possible S values that we could put in there, all the possible values of S that we could input into this equation, would be the domain of the equation. So we got to ask ourselves, is that discrete or continuous? Well, we couldn't put in a partial shirt. We couldn't put in 1.5 shirts because Joe won't sell half a shirt. So we can only put in discrete units of shirts. And so the domain of this function is discrete. I think that was pretty easy, and I hope you do too. So now it's time to test your skills and make sure you understand this. Go to www.mastermath.info and download and do the worksheet titled Discrete versus Continuous Domains. Then go back to MasterMath and try your luck at the subject quiz. I hope you enjoyed yourself, and I hope we see you again real soon.